Hi, I'm Steve Mills, a Solutions Engineer here at Oracle. You perhaps saw my previous video on Oracle Communication Service Availability Machine, where we really took a look at OCSAM from a technical point of view. And we used this deployment view map of the various compute assets, both software and hardware, that come together to support the OCSAM overall system. We talked about the NEPs compliant hardware, the carrier grade software, the blending, the testing that really allow for you, the customer, to really think of it as an application-ready platform. We talked about the interfaces facing towards your applications that you would integrate with to enjoy the services of the middleware, and we talked about the interfaces that you would need to integrate to actually manage your integrate with your management solution. And you can treat this as all as black box because we've taken care of it. Now, we're going to, in this video, really talk about availability management. And so to that extent, we're over here in this a more focused view of the same deployment view where we really start peeling the onion and looking in the OCSAM layer. To that extent, we're talking about software redundancy. You can never have too much of a good thing. And the core thought, overall paradigm that we need to consider is the fault management cycle. Now, in the fault management cycle, we start with fault detection, or we start with health. It's a healthy system. In real time, we detect a fault. Based on that fault, we isolate those resources that are dubious, that are in doubt. From there, we automatically engage some recovery policy that will make sure that service availability is maintained, even in the face of that fault. And then, optionally, we can engage the repair, which is to say that after we've recovered, there's dead resources laying around, and if so enabled, the system will automatically try to resurrect those dead resources and bring them back into the fold so that they can, again, participate in the overall protection scheme of the system. Now, from the time of fault detection to recovery, we're talking sub-second recovery times. We've had customers do it in as little, have failovers in as little as 20 milliseconds. Numbers could be anywhere from 500 milliseconds to a second or more, and really most of that time budget is driven by the nature of your applications. So let's talk a little bit about the availability management and how it really helps with that fault management cycle. In this OCSA layer, there are three services. Availability Management Framework oversees the health and availability of your applications, and your applications are really the key thing. That is, at the end of the day, whatever your device does, it's the software, your applications that are bringing the value to market. And so it's these applications that have to be made highly available. So in the face of a fault or a failure, there's software failure or whatever it takes to make sure that service is maintained throughout, even though there's that fault. We also consider cluster membership. Cluster membership is really understands the set of nodes and whether or not they are present, so that as to form a cluster. And so in this particular diagram, we show three blades, our 6270 blades. We imagine an instance of an operating system on each. That would be a three-node system. A node generally maps to an instance of an operating system, and on there software lives. Now, in future versions, of OCSAM, we're going to introduce virtualization. So in that case, you can have one physical blade that can house multiple nodes, that is multiple virtual machines, each with its own operating system. And so we come up with a bigger, richer system in future evolution. But cluster membership, again, is once it identifies the presence of those nodes and the health of those nodes, it continually monitors them to make sure that they remain within the scope of the cluster and monitors the health. Then finally, platform management. Platform management is a model of the field replaceable units that make up the overall system. And through that modeling, we understand things like version numbers, serial numbers, patches, any number of detail points that keep us in tune with the various physical assets that make up the system. More important, however, is the fact that we understand the state of that physical hardware, so that we can make decisions about availability. We can have administrative means to actually control the state of those physical assets, so that we can, for example, quiesce a node, forcing the migration of these actives over to wherever the standby lives, so that we can do maintenance, for example. And we also have instrumentation in there that really understand various sensors such as voltage and heat, so that if thresholds are crossed, we can take proactive action at the application level because we know that this node is going down, and proactively we can migrate any key assets off of that blade before it actually goes. So between the hardware at PLM, the middleware itself and the various compute contexts, the various nodes that make up the cluster with CLM, and then finally AMF, we have a complete picture of the availability that makes up your system. We want to focus in on AMF with we want to dig in a little deeper here. And we'll appeal to the notion of what a system designer is actually thinking when they're actually building a system. They are going to be doing a modeling exercise. That is, they are going to lay out mentally where the various components, these are processes, are going to live on the system, and they're going to lay them out on where they're going to live. They're going to lay out the policies and procedures that should be engaged in the advent of a fault, and they're going to do all that by filling in this XML file, which is a well understood syntax and semantics that really represents a collection of modeling objects. And those modeling objects each have a collection of attributes, and those attributes will be assigned various values, preordained values, things like, in the case of this modeling abstraction called a service group, you would within the scope of that service group, you would declare what the redundancy model is that's going to be applied. And so in this case, it's N plus M, that is 2 actives and a single standby. You're also other characteristics of the modeling is you're going to say, for example, that this process apparently has a dependency on this one, so that the order in which they'll be instantiated by the middleware is affected so that they come up in the right order. You can also rank the various environments so that you can steer the system towards a world where the actives will live in known places, preferred over where the standby lives. So based on ranking, this was made active, and this was made active, and this was made standby, as the system has a natural tendency to try to migrate towards that preferred configuration. Now, the system designer, when he lays all this out, is also, from an application writer's point of view, working to see that the two are coordinated. So there's this AMF library here, and it's through that AMF library that you link into your application that the component itself understands through callbacks, whether it's to act as an active or act as a standby, which the AMF will invoke at the proper times, at failover times or at startup times or whatever time it is. Now, AMF supports both this intrusive model of where you have to write code around the libraries. There's also, for legacy applications, a way to do it in a non-intrusive way so that your applications can really participate in exactly the same redundancy schemes, but not necessarily have linked-in libraries. Now, in that case, generally your failover times aren't going to be as fast because when your application is aware of the fact that it's active or standby, it can participate in active standbys where the standby is actually incarnated and ready to go. So at failover time, the only thing the middleware has to do is make the callback. And so the overhead of identifying the fact that there should be a failover to the time you get the callback, that's where that time budget of about 20 milliseconds comes into play. And so we can be quite fast in terms of that failover. So that's a brief overview of availability management framework, or availability management services in general that come with the OCSA world. In our next video, we're going to be talking about systems management, and I hope to see you in that video. Thanks so much. See you later.